Sonia, just mute your line a bit. Okay, we are going ahead now with the basic idea of differentiation, which you have in this chapter. So let's first understand, before going to differentiation, let's first understand how that long formula comes and what is the idea of differentiation. Can I have one new textbook, please? Just wanted to see from where they have started it. Okay. Now, first understand this concept, then everything will become easy. Okay, let me use the different, what you call, so yeah, so good. Okay. Let's analyze two scenarios. Right. This is say okay. This is X and this is Y axis. This is Y axis. This is X axis. Now, enjoy this discussion. Okay. I have a line. This is called straight line in mathematics. Straight line, standing line, sleeping line. So this is a straight line. And I tell you, calculate the slope of this line. Okay. Now this line has got a constant slope. Do you have fair bit of idea about slope or not? Okay. If you don't have, then say suppose there is a line. There is a line like this. What do we mean by slope? The first thing, slope means the inclination of this line with the x-axis. That is actually given by this angle with which it is inclined. If the angle is acute, the slope is positive. If the angle is obtuse, the slope is negative. Angle 90, slope is infinity. Angle 0, slope is 0. Have you understood? Okay. Our job is to calculate, and on a line, the slope is always constant. How to see? Make positive direction of x-axis anywhere. You find that these angles are all theta because they are all corresponding angles. So a line always has a constant slope. Is this understood or not? So if I ask you, calculate the slope of the line that I have drawn here, you can calculate this slope anywhere. Agreed? Because slope is always constant. And to understand it in a crude manner, make a boy stand here, sit here. He will slide down without any jerk. He will slide, that's very unhygienic. He will slide down without any, okay, I'm sorry. So I want to calculate the slope of this line. I can calculate the slope anywhere because the slope is constant. Make a child sit here, the child slides down without any bump. So in order to calculate the slope, what we do, we take any 2 points, okay, children? If you don't understand, don't hesitate, just ask me. I take 2 points, right? And what I do, I go by my grade 9 idea that slope is always given by the simple formula of rise over run. Is this thing understood? Let me say that these 2 points are P and Q. This is known as rise and this is known as run. Rise over run gives me the slope. Rise over run. Is it understood? Any doubt at this position? No issues? Clear? Okay. Now, all rise taken upward is positive. All run towards the x-axis this side is positive. If you run this side, then it is negative. If you rise this side, it is negative. Say, for example, my line was like this, right? And now you want to calculate rise over run. If your run is in this side, it is positive. Means from this point, you have to reach this point. Or from this point to this point, either your wish. Let me reach this point. My run will be positive, but my rise is negative. So obviously it's a negative. Let's see from this side. Rise is positive, but my run is negative. And you are supposed to move like the rook of chess. You can only move horizontal and perpendicular, right? So if I go by my grade 9 formula, my slope is rise over run. Since you know trigonometry, can I not say that tan theta is also equal to slope? If this angle is theta, tan of theta is also equal to slope. Understood? This measurement is a measurement on difference on y-axis. Let me call this as delta y. Some delta y this is. Do you agree or not? And this is some delta x. So my slope is also delta y by delta x. Is this clear or not? Understood? All these are fine when we are dealing with line. Now say suppose I have got something like a curve out here, and I tell you find the slope of this curve. Life becomes difficult. Find the curve, find the slope. Sir, where do you want to calculate the slope? Sir is being very, I want to calculate the slope between P and Q. Calculate the slope. So sir, go by this approach. I can't, because this is not a line. This is what? A curve. I can't do it. So I say, I cannot calculate the slope here, but hypothetically, if I bring down Q to some position here, say Q is brought down here, it looks like a line, at least for this diagram. And I can go my approach of rise over run, which is a delta x over delta y. But at that time, Zoe starts questioning, sir, you are watching it in the diminished form. If I bloat it up, it is still a curve. I said, yes, there is a problem. It is still a curve. So how can you apply? So I said, Zoe, let's do one thing. Let's bring Q more nearer here. Zoe, now you can't disagree with me. This is a straight line, PQ. She says, I will again bloat it up. This is still not a straight line. So the argument continues. Are you getting the argument? What will be my next step? Bring Q more nearer. She again bloats up the diagram. So I say that I pick up two measurements. Okay, I pick up two measurements. This is one measurement, right? This is one measurement. This is one measurement, and this is one measurement, right? I say that this is a function y equal to f of x. Understood? Right? So if this point is x, then what is the coordinate of this point? Fx. And since Zoe is continuously trying to derail my logic, I said, Zoe, I am now moving a very small difference. She says, no matter how much distance you move, I'll keep on bloating it up. So I say I move a very small distance from here to here, and the distance I'm moving is only h. What is this distance? H. So the next point becomes what? X plus h. So what does this point become? F of x plus h. Is this understood or not? And I tell Zoe, look Zoe, the slope is equal to the delta x over the delta y, and the delta x is, the slope is equal to delta y over the delta x. And what is the delta y? The delta y should be, look at the delta y. The delta y is only this much portion. Do you agree? Achha. If you're unable to understand, then let's keep this. Right? And children, this is the delta y and this is the delta x. Agreed? I say that my delta y, what is delta y if you see? F of x plus h is a measurement from here till here. If I take out f of x measurement, means this much, don't I get delta y? I do. And I divide it by x plus h minus x, which is nothing but h. Do you agree or not? X plus h minus h. But our friend is still saying, all this is understood, sir, if PQ was a straight line, which it is not. She says, no matter you do this, I'll again stretch it out and I'll prove that this is a curve. Now I have to silence her once for all. And I say, my h is very small. She says, how small? I say, slope is equal to limit of h tends to 0. You can't even think, it's very small, just from x to a little bit. Now you can't say it is a curve. It is almost a straight line. And then I am seeing what? Delta y by delta x. I have introduced this additional condition. This is just to silence her. Otherwise, every time she's expanding this graph and trying to prove me wrong. Now h is very small. To show you, I have drawn here. But h is where? Between the two eyelashes, h is there. Between that to the line. Ananya, you're getting it, right? The logic. Now it is a straight line. Now, girl, you can't deny me. Then this changes. And this ratio is called dy by dx. This is delta. This is del. Even smaller. This is average velocity. Del x by del t. This is instantaneous velocity. Average is always between 2 points. This point and this point. Imagine this is a distance curve. Distance. Look here. I am seeing Neha here, 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 here. They say observe Neha between two close points. Still my eyes are moving. More close. Where do I see? Neha at one spot. Instantaneous velocity. If it was a VT graph, it was instantaneous acceleration. But when I'm seeing Neha here, Neha there, time elapsed, average velocity, average acceleration. Are you getting the? And this, the formula that your book uses is limit of h tends to 0, x plus h minus f of x divided by h. This is all about differential calculus. So next time you hear differential calculus, you are only calculating slope, 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 slope. Remember class 9 first chapter? Slopes. ST graph, VT graph, AT graph. And when you do integral calculus, you will be calculating area, 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 area. All areas under the curve, slope of the curve. Bolo bacha, this much have you understood or not? So what you should understand, what is del y by del x? This in physics always gives you an average measurement, whereas a dy by dx gives you a instantaneous measurement. Is this understood? And the instantaneous measurement dy by dx, at that time we say this is when limit delta y tends to 0 and then delta y by delta x, this is this ratio. I have written h tends to 0, h is nothing but delta x in our question. And you should understand it like this. Sit at the side position and watch a tennis match. Tuck, tuck, x, x plus h. Bring them closer. X plus h. More close. X plus h. Very close. They are both at the nets. You don't see them moving. Instantaneous position. Hope you have understood this desi logic which I tried to explain. So initially there will be some problems. We may break 5 minutes earlier. Huh? You heard the call, right? Some people are down waiting to eat my head. So initially we will do the problems where you are supposed to use this formula. But this formula is actually making the dosa batter in the grinding stone. You will sweat out. So we have to have some standard formulas. And differentiation is all about standard formulas. Fine. Did you get the logic? So can I change and write a bit? My hands are itching. Okay, I'm just changing the screen. Anyway, video will go to you. See, so we write like this. Given a function y equal to fx, given a function, mark my words, given a function y equal to fx, the derivative of y with respect to x. Remember, you always differentiate with respect to the independent variable. Y is the dependent variable. If I put x here, then only f of x will come out. Is called dy by dx. Wait, don't write anything, just see. Which is not that you cancel d and d together, which means you are differentiating y with respect to x. ddx is called the differential. Differentiating y with respect to x, which can also be written as ddx of my function fx, understood? Which can also be called as the derivative of the function f dash x, which can also be called as y dash. This is Neha. Her parents call her Chinky. Her grandparents call her Minky. Somebody calls her Lovely, and all these same names for the same derivative. So don't get confused on all these things. Y equal to fx is a function. The derivative of the function with respect to x is called dy by dx. So what is our common language? Maggie. Any noodles is Maggie, dy by dx. Exact word is del y by del x. Means ddx of y. ddx of y. You are differentiating y. With respect to what? With respect to x. तो करेला घिस ले हाथ में, फिर और नहीं खाएगा. With respect to y, all germs are entering your mouth. These are good with a class 6-7 boy. Here at grade 12, how do you keep on chewing nails? Which is called the first derivative, fx. Understood? Another terminology, let us see. You obtained the first derivative, right? Now, suppose first derivative is also a function. It is also a function. Now I want to differentiate the first derivative. I want to differentiate the first derivative. What do I get? I get the second derivative, which I also call as f double dash x or y double dash. This is the second derivative. Second derivative. Another way to understand this is, my function was y. I tried to differentiate y. What did I get, children? I got dy by dx. Agreed? Now I am trying to differentiate dy by dx. As the same thing. Dy by dx is f dash x. There are different names. What do I call it? I call it as d2y by dx2. We don't call it d square y d6 square. d2y by dx2. This is the second derivative of this. Original first function, first derivative. Differentiate the first derivative, get the second derivative. Shall we go to the third derivative? Why not? Let us further differentiate the second derivative. Then what do you get? You get the third derivative. Sir, in the language of y, triple dash. Sir, in the language of fx, f triple x. fx is the function, grandfather, his son, f dash x, his son, f double dash x, his great grandson, f triple dash x, dy by d. Achha, y is the father, first generation, dy by dx, second generation, d2y by dx2, third generation, d3y by dx3, nth generation, dny by dxn. That is the nth derivative. Concept is getting clearer? Very good. You are very good people, intelligent children, only that you don't practice at home. Rest is all fine. Shall we? Shall we? So initially we'll differentiate some functions with the first formula. First formula is laborious. Nobody in exam will ask you to use first formula. ये चीज बच्चा समझ में आया तो? First of all, did you understand what is dy by dx? Second, you understood that it is not only one derivative. You can have one derivative, second. For example, displacement's derivative with respect to time. Let's go to physics. Displacement is s. If you differentiate displacement with respect to time, you get something called velocity. Do you agree or not? And how to read this? Enjoy. The graph of ST graph always gives you velocity. Sir, I did not understand. This is S measured in meters. This is T measured in second. You're trying to calculate slope. Slope is always del y by del x. Whatever measurement you get, the slope will be some meter on top and second below. This is what? Velocity, meter per second. Right? This is, yeah, 1 minute. So this is velocity. Have you understood? If you differentiate displacement, let us differentiate velocity with respect to time. In place of velocity, what can I write? Velocity is this, na? ddt of ds by dt. This is what? d2s by dt2, also known as acceleration, the differential of velocity. Acceleration is the double derivative of displacement, right? So in our graph, we have what now? We have a v graph and a t graph. V is in meter per second, t is in second. Meter per second divided by second. You are getting a quantity which is meter per second square, and this is nothing but acceleration. Clear? Right? Can I now take a problem? Have you understood the basic idea of what is derivative? Derivatives can be found in 1 generation, 2 generation, 3 generation. Don't break your head. Things will become more easy now, slowly. Let's take one more example. Let's say, given a function f of x is equal to 2x plus 3, please find the derivative f dash x with using the formula. Right? So let us write. F dash x is given by what? Say, since y is not mentioned here, so we are not mentioning y. We say f dash x is given by the formula limit h tends to 0, f of x plus h minus f of x divided by h. Do you agree or not? But h, अभी ना स्केल से मारूंगा, लेकिन ना मेरा ऐसे ही दिमाग गर्म है, मेरे सामने मत करते रहो ये. You are a grade 12 बच्चा. This is h. Sorry, she must be thinking why he flared up. Why I flared up? Because I have one unhygienic person here. So this is h. H tends to 0, you can't put. It will become 0. So let's put. Okay, let's read this function. F of x is 2x plus 3. What is f of dog? 2 dog plus 3. What is f of cat? 2 cat plus 3. So what is f of x plus dog? 2 into x plus dog plus 3. Instead of x, we enter x plus h. Understood? This is x plus h. Think it to be dog. Just enter dog here. So what do you enter? 2 into x plus h. The whole function is x plus h plus 3. This is f of x. Children, f of x plus h. This whole thing is to be read as 1 and take it out and plug it in place of x. Clear? And then I should do f of x, which is what? Niche what? Clear? Shall we? So this is limit h tends to 0, 2h plus 2x plus 3 minus 2x minus 3 divided by h. Clear, bacha? Plus of 2x, minus of 2x, plus of 3, minus of 3 gone. Limit h tends to 0, 2h by h and h gone. Answer is 2. The derivative is 2. This is by the grind method. By Mixi, you will solve it in one line. Shall we do one more? F of x is equal to x square plus 1. Children, when you will be doing by Mixi method, you will straight away say that the answer is 2x. Let's see whether we get 2x or not. Answer for this is 2x. So what is f dash x? Limit h tends to 0, f of x plus h minus f of x divided by h is equal to limit h tends to 0, put x plus h whole square plus 1 minus x square plus 1. Children, this step did you understand or not? Tell me. This step did you understand? Neha, be very careful. Ye samajh mein aaya to? This was our dog. So we have put dog in place of x. Limit h tends to 0, x square plus 2hx plus h square minus x square minus 1 divided by h. Clear, bacha? There is a plus 1 also which I missed out. Plus 1 minus x square cancel. Limit h tends to 0, 2hx plus h square divided by h. Correct? H square and h gone. Limit h tends to 0, 2x plus h. Right? Something is garbar. Oh, wait. Something is garbar here. What has gone wrong? Just check this. A square plus 2ab plus b square. X square gone, h gone. Yeah. So this should be 2hx plus h square by h square gone. So you are left with limit h tends to 0, 2x plus h. So your answer is 2x, which I already told you. Understood? So you are ready for your first formula of differentiation. First they will ask you to differentiate by this. Exams, these don't come usually. Exam, you will get the tougher differentiation. So your first differentiation. All formulas should be by heart. Otherwise, no point in attending next class at all. If your function is in the form ax to the power n, then your derivative is always n a x to the power n minus 1. In books, you will find y equal to a x to the power n, then dy by dx is given by a n x to the power n minus 1. Let us see something as a function call, say 2x plus 3, y equal to 2x plus 3. Children, y equal to 2x plus 3, since you have understood now composite functions also, y equal to 2x plus 3. Can I not write this? Can I not write my y as two functions, say g of x plus h of x, where this function is algebraic, this is a constant function. Do you agree or not? A constant's derivative is always 0. Sir, I don't believe what you are saying. So much of problem. Y equal to 3 is a line which is at 0, 3. What is the slope of this line? Constant's derivative is always 0. Write it. A constant's derivative is always 0. You got this formula? Right. Now let's see something more. I have got a function y equal to linear function ax plus b. Right? The derivative of this function dy by dx is nothing but by calculating the derivative of this whole ax plus b. Differential calculus allows me to break and do the derivatives separately. This is still a function of x. This is a constant. This will come 0. So the derivative only depends upon the terms that contain the variable. Understood? Acha, see one more thing. I told you if your function is a x to the power n, then your derivative is a n x to the power n minus 1. Some more interesting things come out from here. See, if you are a nth power, your derivative is n minus 1. That means if you are cubic, your derivative should be quadratic. If you are quadratic, your derivative should be linear. And if you are linear, your derivative should be constant. That means, just look at these examples that we had done so far. Look at this example. What is the function we started with? Linear. What is the derivative we got? Constant. This is 2x to the power 0. Let's see the next example. What is the derivative we started with? Quadratic. What is the derivative we got? Linear. If you take a cubic, you should get quadratic. Is this thing getting clear now? That means if I take a parabola, its slope will be a straight line. Parabola is quadratic. Quadratic slope is, what is the slope of a quadratic? Linear. Linear is a straight line. That's why you used to say that the slope of a parabola is the tangent to it. Tangent is a straight line. Now you're understanding. A lot of things to absorb in one go. These basics, once it becomes clear, your job becomes clear. Chalo, let's take our same example. F of x equal to 2x plus 3. Right? Let's do the derivative now by, and I say my problem is y equal to 2x plus 3. Find out dy by dx using the formula. So dy by dx is what, beta? ddx of 2x plus 3. And it allows me to go by term. This is what? 0. Constant derivative is 0. What should be its derivative? Here, use that formula. A x to the power n. You are having 2x to the power 0. Not 0, 1. 2x to the power 1. So what should be the derivative? The derivative is a n x n minus 1. So you retain your 2, you bring your 1, x 1 minus 1, which is 2 into 1 into x to the power 0, which is 2. And afterwards, automatically it will come to you 2. So the answer is 2. But in the next problem, we took y equal to x square plus 4. So what is dy by dx? Right. Now don't go this way. Look at me and we'll calculate. Whatever is here, put here. 2x1. 2x1. What is the derivative of x to the power 7? 7x6. Did you understand? Yeah. 7x6. What is the derivative of x cube? 3x square. What is the derivative of x to the power minus 3? Minus 3x minus 4. Is it? No. Yes. nx n minus 1, beta. This derivative is minus 3x to the power minus 4, which can be written as minus 3 by x to the power 4. Whenever it is a negative, look at the trick. Whenever it is a negative, put the x down, retain the negative on numerator, and increase 1 by the positive on the denominator. ये धीरे धीरे आएगा आपको, slowly. चलो, let's differentiate one tougher problem. Shall we? Let's differentiate one tougher problem. Our problem is y equal to x plus 3 whole cube. So y can be written as what, beta? Tell me. Y can be written as x cube plus 9 plus 3a square b. That means 3 into 3 is 9 x square plus 3ab square. That is 9 into 3, 27x. देखो तो, am I correct? A cube plus b cube plus 3a square b plus 3ab square. ठीक है? Okay. Though I will allow you, but you look into the board and my face. Come quickly. This is how we do differentiation. Differentiate this. 3x square. The 9 becomes 0. This will become 18x. 291. And this will become 27. Done. So easy. You started with what? Cubic. What did you get? Quadratic. Come on. Let's do more. Let's double differentiate it now. Differentiate this one. Look here. 6x plus 0, 18. This becomes 0. It still has a variable. Let's further differentiate it. d3x by dx3. 6. Till you get a constant. You can go on differentiating. When you study integral calculus, integration of this will give this is this, and this will give this. Integration is the ulta of differentiation. This is called derivative. We call integration, if you study in US, they will call it as antiderivatives. They will call it as antiderivatives. Is this much clear? Next will be a series of formulas of trigonometric derivatives. So I'll cut short today. I will give you one exercise. Okay, your homework, you take a homework. Let us see whether you are able to do. Your homework will be, bacha, all are sin x cos x. You can't do sin x. Oh, they are all asking you to do by first derivative. 5.3. Oh no, we have some more exercise. 5.2. Okay, where is 5.1? 5.1 is continuity, na? 5.2 is again all this thing. Okay. Write down. I am writing some. Write them down. These are your homeworks. Do them all by first formula. These are by first formula. Which one? The limit formula. Okay, do them. Got it? And do these two, you do by nx n minus 1. This is your homework. Got it?